All right, y'all. So we've been talking a lot recently about factoring, and the reason we're using factoring is because then, once something's factored, we can use the zero product property to find the roots, and I'll explain a little bit about what that means in this video. So something that you know is true for multiplication is if I have two numbers that multiply together, that equals 0. So like in this case, we're using general ideas like A and B. If I multiply two numbers and they equal 0, then either A is 0, because 0 times whatever B is, B could be 4. If A is 0, then the whole thing is 0. Or another situation is possible. Maybe B is 0. Like A could be 22. 22 times 0 is 0. So to get 0, either A has to be 0 or B has to be 0. And I'll talk a little bit more about what that is. Well, what is A and B? Well, so far you've been factoring things. Factoring things into the format of A times B. And these things are going to change. But if they equal 0, it means one of two things. Either A is 0 or B is 0. And we're going to talk way more about that in depth. So the key takeaway here is that if the function is 0, if two numbers multiply together to be 0, then one of two things is true. Either A is 0 or B is 0. And that's really important because in this case, A would be that thing and B would be that thing. So we'll talk about how that's useful in a moment. So if we look at these equations and we see that, like, for example, the first one, if y times x minus 3 is 0, then one of two things is true. Either y equals 0, because 0 times whatever is 0. Or maybe y is not 0, maybe y is something else. Or x minus 3 is 0. That's a possibility too. Well, if x minus 3 equals 0, we can do a quick solving. We can quickly solve it so that either x is 3. So for this problem, if y is 0 or x is 3, then the whole thing equals 0. Let's take that one more. Let's try that again with the new problem. If this is puzzling to you, be sure to come to the office hours this week. So x plus 5 or x minus 3 equals 0. That either means x plus 5 equals 0 or x minus 3 equals 0. Well, if x plus 5 is 0, a quick solving would mean that x equals negative 5, or quick solving, that would be x equals 3. Either x is negative 5 or x is 3. And I'll show you what that looks like. If x happens to be negative 5, then x is negative 5, x here is negative 5. Negative 5 plus 5 is 0 times negative 5 minus 3 is negative 8. Well, 0 times negative 8 is, of course, 0. So the reason why we spend all this time is that we want to see what could x be that makes this thing 0. The last one is a little bit tricky because it requires a little bit more work on your behalf. So if this is true, either 2x plus 8 is 0 or x is 0. Oh, that's easy. Either x is 0 or 2x plus 8 equals 0. Well, to solve that, subtract 8 from both sides, so 2x equals negative 8, divide by 2, so x equals negative 4. So either x is negative 4 or x is 0. I'm going to grab the phone and I'll restart. Sorry about that, but we're back. So when we're thinking about what makes it 0, for each of these you could do this. So I'd like you to pause the video and I want you to try these, and I'm going to go over each of them in just a moment. We're actually going to use these in the next video, so I need you to write them down even if you just pause the video, because we're going to use them in the next step. So please pause the video and try to find the value of x that makes each of these expressions equal to 0. You're going to come up with two answers for each. So x equals something and x equals something else. So hopefully at this point you have solved each of these. I'm going to do them very quickly, and I'm color coordinating them for the next page. So you should set each part equal to 0, so x plus 3 is equal to 0, and then x plus 1 is equal to 0. And we're going to quickly solve. So x equals negative 3 is one of the options, and x equals negative 1 is also the other option for the first one. And then we're setting both parts equal to 0. And we're solving for x. X equals negative 1 is one option, and solve for x. X equals 2 for the other option. Set each part to 0 and solve each part. So x equals 3, and x equals 1, and set them both parts equal to 0 and solve for x. This should be pretty repetitive because it really is the same procedure every time. You're setting each part equal to 0 and then solving for x. Now I'm going to slow down on this these last two because there's a piece of information that's core here. Remember, you're setting them equal to 0 and then solving for the x value, but we've got this 2 in front there, so we need to consider that as we solve it. So we're going to subtract 1, and then we get 2x equals negative 1. Now we have to divide both sides by 2. And we actually get a fraction, negative 1/2, which is the same as negative 0.5. So either one, whatever works for you, is fine. And the last one is the same as it's always been. X equals 4. And this very last one, I hope that you notice that x plus 1 and x plus 1, it's going to give me the same answer twice. So I really only need to do it one time. We say that this has a multiplicity of it has a multiplicity of 2 because it's the same answer twice, but that's for another time. So x equals negative 1. There's only one answer, but that answer happens twice. So go back through, and if you need to review any of these, pause the video and rewind. All right, so why do we need this? Well, we need this. These are the same equations as we had before. We need this because our goal is to graph them, and we're using the factored form to graph. The reason we set them equal to 0 was because the y value is 0. When you set something equal to 0, it means the height is 0. So we found the two x values for each of these where the height of the function is 0. So which graph matches the x-intercept of negative 3 or 1? Well, if I take a look here, the x-intercept is negative 3, the x-intercept is negative 3, and the x-intercept is negative 1. It matches A. So the answer to 2 is the problem A. Go ahead and pause the video and try and match the rest of these. In a few seconds, I'm going to just miraculously make the answers appear. All right, so at this point I've done all of them except for the last one. I want to pay special attention because the x-intercept is negative 1/2, and a lot of students get confused about that. It actually goes here to 1, but I want you to see that if I go all the way negative 1, it's negative 1, but I'm going halfway through to negative 1, so it's negative 1/2, and the other spot is 4, so this lines up with part E, so answer E. Go ahead and pause the video. I want you to practice factoring, and this one you're going to use the greatest common factor, and also set it equal to 0 to solve. So pause the video, try it out. You're going to find what values make it 0, and factor. All right, so a common factor here, it looks to be 2x squared because 6 is divisible by 2, negative 8 is divisible by 2, and they both have, there's x to the third and x to the second, so they all have a couple of x's in there. So we're going to pull out 2x squared, and what's left over is going to be 3 because 2 times 3 is 6, and x because x squared times x is x to the third, and then it's still a negative. 2 times 4 is 8, so that's where the 4 comes from, and x squared times 4 is a negative 8x squared, okay? So this is the factored form. If we set it equal to 0, then we can determine, okay, when does 2x squared equals to 0? Well, this is our zero product property again, because 2 is never going to be 0, so it's when x equals 0, or when 3x minus 4 equals 0, and we got to solve. So 3x equals 4. So divide by 3. It's when x equals 0 or x equals 4/3. And I'm just going to leave it as a fraction. Those are my two answers when I factor and set it equal to 0. This is the last problem. I want you to practice factoring it and setting it equal to 0 so you can apply the zero product property. Hopefully you've taken a moment. Remember that factoring, you're really thinking about 7x squared and negative 20 and what two values multiply to 7 times negative 20 and add up to negative 4. So that means we're looking for something that multiplies to negative 140 because 7 times negative 20 is a negative 140 and adds to negative 4 because that's our middle term. I'm going to make a list of possible values, and I'm going to use something that's a little, I'm kind of going to get a little closer because I know that the numbers have to be close together. Like negative 1 and 140 is not going to really make it close to negative 4. So I'm going to start here with negative 14 and 10. Oh, hey, actually that worked. That was the first guess got it because negative 14 plus 10 is negative 4. So I don't actually have to do all that much work. Negative 14x and 10x. Find common factors. A common factor here is x, it looks like. So that's got to be 10. So this has to be negative 2, which makes that have to be 7x. So my factored form is 7x plus 10. That's the stuff up here. And my other factor is x minus 2. So another format of writing this is 7x plus 1 times x minus 2, set it equal to 0, which means that we're going to really break it into two pieces. 7x plus 1 equals 0, or x minus 2 equals 0. Minus 1, so 7x equals negative 1, or x equals negative 1/7. And then our other idea is plus 2, so x equals 2. And these on a grid would be where it crosses. So it crosses at 2, and it crosses at negative 1/7. And our parabola, the curve is probably going to look something like this, but we don't know for sure. That's our goal moving forward. I hope this video was helpful. I know that it was long, so thanks for watching to the end. Remember to factor. If you need help going back, remember to factor so that you can do zero product property. Thanks so much for watching.